Okay, so here's the first problem that we have, and they want to know what x and y is. And sometimes this problem can kind of be overwhelming because they want two pieces of information and they only gave you one small tiny piece. But that piece is actually a lot because they told you that this thing was regular. And if you know that it's regular, what you get to know from that is all the sides are the same. So that's 7, that's 7, that's 7, that's 7, and this is also 7, but really it's probably easier to think of as 3.5, 3.5, because it looks like they perpendicularly bisected that. So now what I think the easiest thing to do is, if I only know y is this line right here, a lot of times making triangles is easy to find what these things are, so we're going to make a triangle. And you might go, well then what is this angle right here? Well, what you should know from this being a regular polygon is that all the sides are the same, which means all these angles are the same. And you should know that if you have any polygon, it's made up of 360 degrees. And since we have 6 sides, which we can count 1, 2, 3, 4, 5, 6, we should divide this by 6. We know all the interior sides are 60 degrees. So that means this is 60 degrees, that's 60 degrees, all of them are 60 degrees. So this triangle that we have right here, 60 degrees right here, well if that's 60 degrees and that's 90 degrees, what's this? Oh, that's easy enough. That's going to be 30 degrees. So this is a 30, 60, 90 triangle. And since it's a 30, 60, 90 triangle, and this is across from our 30 side, we know that this would be double, or side y would be 3.5 radical 3. Because this would be our x side, this would be our 2x side, and this would be our x radical 3 side. So we found what y is. Now you might also go, man, how am I going to find what x is? And that looks like a daunting task, but again, I just look at this and go, oh, I can make another triangle. Well, we know that this is a 60-degree angle from before, and we know this is a 60-degree angle from before. So this would also have to be a 60-degree angle. And so if they're all 60-degree angles, that means they're all equilateral. So that means this side is as long as this side, which is as long as this side. So if this side is 7, this side would also be 7. So as you kind of do this style, first I would make sure you know what regular means, which is all the sides are the same. And then second, you want to work with the angles, which means all the angles are the same, so that's not too hard to find. Then after you've done that, you want to remember your 30, 60, 90 rules for triangles to find that. We'll do the next example. Okay, I'm going to explain the second one a little bit better than the first one too, because there's a theorem that I forgot. I took a little break and kind of read up on because I was like, I think there's an easier way to do it. So the theorem that I forgot is, basically, if you want to find the central angle, which a central angle is any, if you connect any two adjacent sides or two adjacent corners, so that corner and that corner, that's a central angle because if it meets in the middle. You can find the central angle by doing the same trick we did before, like 360 divided by how many sides there are. So the central angle in this thing would be 360 degrees. Divided by 1, 2, 3, 4 sides. So the central angle of this thing is 90 degrees. And one other cool thing that happens is this central angle, if it is cut by what we call the apothem, it bisects it. And bisecting means cuts in half. So when I'm looking at this thing right here, I can tell that its central angle was 90 degrees. And this cuts it in half, so if this was 90 degrees, this is now 45. And this would obviously be then 45. Well, 3 is already really easy to tell out what that angle is because it's a supplementary case. Like if this is 90, this has to be 90 because it's got to be the whole 180. So that's 90 degrees right there. Well, if this is 90 degrees and this is 45 degrees, well, this would then have to be, you guessed it, 45 degrees because it's got to equal 180. And we already said, like, the central angle, this again would be a central angle because corner to corner, that's going to be 90 degrees. So a lot of this stuff is figured out by the central angle, and the central angle you can find every single time by if it's connected in the middle, corner to corner. It's just the same thing that you do to find any of these angles in here. Let's do another example. Okay, I'm going to do a second example of this angle type because I think I can do a little bit better job of explaining this. So again, what we want to do is find the central angle. So these are all, as you can see, central angles in here. Whoops. And so we again always do 360 divide how many sides there are. There's 1, 2, 3, 4, 5, 6 sides. So all of those are 60 degrees. So all these central angles are 60, 60, 60. So I know what this is already. That's 60 degrees. And again, we know that this thing right here cuts that in half. So I know what 9 is. That's 30 degrees. Well, if this is 30 degrees and this is 90 degrees, well, what does that have to be? Oh, that's a 60 degrees because that would have to be a 30, 60, 90 triangle. So that's how you do these ones. Again, I'd start with your central angle and just realize after your central angle that this will cut it in half, and then you kind of look for your 90s and triangles and kind of how it's made up. Let's try another example. Okay, so now what they wanted from this thing is they wanted the area. And so the only way I know how to find area of this is 1/2 apothem times perimeter. The nice part was they gave me the apothem. And the apothem is 4. So we're already halfway there. So all we have to do now is find the perimeter. And you might go, well, how am I going to know what one of these sides are? And, well, what we're going to do is we're going to use that central angle that we learned about before and kind of use that to help us find all the other information. And so what I'm going to do is I'm going to use that central angle thing that I know. And I know this would then be 60 degrees right there. And because that's 60 degrees right there, we're going to use a couple more pieces of information to then start figuring the rest out. Okay, I took a brief pause, and the reason I took a brief pause is I didn't realize, I was like, oh, I can't actually solve that. And the reason I couldn't actually solve that is this is not the apothem, which is good for us. This is the radius. So the radius tells you where all these 4 like lines in the center connect. And that's like 4. That's 4. The apothem is what cuts these things in half. So the apothem for this thing is this like 90-degree angle there. And so, because we know this is an equilateral triangle, and because we know that that central angle right there should be 360 degrees divided by 3, that central angle will come out to be 120. And then, because this thing cuts it in half, you know that's going to be a 60 right there. So if you're looking at this, you're like, oh, I see what we're getting. We're getting a 60, 30, 90 triangle. Well, if that's my hypotenuse, halfway over to the other side, that would be 2. So my apothem is 2. Which means that if I want this little side right here, that's that 2 with a radical 3 on it. Well, if that's 2 radical 3, this is also 2 radical 3. Which means one side of this thing would be 4 radical 3. So if one side's 4 radical 3, this would be 4 radical 3. and this would be 4 radical 3 because again it's a regular triangle. So then we're going to add all these things together, and I'm going to get, why is that a 6? So we're going to get that this is 12 radical 3, and we're just going to multiply all this out. So that would be 1/2 is 1 times 12 radical 3 is 12 radical 3. I'm going to do one more example of this stuff just because I felt like I did a bad job explaining this because I had a couple hiccups in there. So just watch the next example and see if that kind of makes sense. Okay, so we got this triangle. And so again, when I look at this triangle, the first thing I'm thinking of is that's my radius, so I know. And they told me this was a regular one, which is nice. That's my radius, so that's going to connect there. It's going to connect there. These are both 10s. And then we know we have some apothem that cuts this thing in half. And again, we can think about our central angle. So it's again 360 divided by how many sides you have, and we have 3 sides. So that means our central angle is 120. And then because it's an apothem, it cuts it in half, so that's 60. And we can go, oh, this is a 60, 30, 90 triangle. And because the 10 is the hypotenuse, across from our 30 side, or our apothem, would be half that. So that's 5, and this would be 5 radical 3. Well, that again is half that side, so that's 5 radical 3, which means all the sides are 10 radical 3. And then we just get to use the fancy formula we know, which is 1/2 apothem, which is 5, times 10, the perimeter would be 10, 20, 30, 30 radical 3. And if you multiply all that together, oh, you'll get 2.5 times 30, and 2.5 times 30 is 75 radical 3. And that's your answer. Okay? So make sure when you're doing this, again, find your central angle. Your apothem cuts it in half. Let's do the very last one. I think these are the easiest ones. These are the easiest ones by far. So all you have to do for these ones, which is nice because those other ones, they kind of used a lot of extra information. These last ones, they just use the formula. So we do 1/2 apothem, which is 6. And again, you know this is the apothem because they cut that in half. So they gave you the apothem this time. So that makes it a lot easier. And then times your perimeter. And so if it's a regular one, that's 5. You know what that is? That's 5, 5, 5, 5, 5, 5, and 5. And you add up all the sides. So 5, 10, 15, 20, 25, 30, 35, 40. So the slow way is adding the 5s, but the fast way is like 5 times 8 sides. So that's going to be 40. And then 1/2 times 6 is 3. And then that's going to give you 120. And that is your answer. So just remember for the area problems, you're just going to use that apothem formula, like 1/2 apothem times your perimeter. So find your perimeter, times it by your apothem. The other stuff takes a little bit. I would say it's all based off the central angle idea, that central angle is really 360 divided by the sides. And then you're going to know that the apothem cuts it in half. And the nice part is because the apothem cuts it in half, you can make a lot of nice triangles. And most times they're 30, 60, 90 triangles, or 45, 45, 90 triangles, or those triangles that you know how to do. And if they're triangles you don't know how to do, then you kind of get stuck. So a lot of times they make them really nice to work with. So if you have any questions after this, please let me know. Please let me know if any part of this video was confusing, or as you're kind of watching the video, feel free to skip or rewind or backtrack, or if this didn't help at all, let me know that it didn't help at all. It just helps me figure out what's the best way to kind of communicate this to you. So just let me know. Thanks.